All right, well, this is lesson 23. If you're looking for the notes, it's on 126. And today, what we're going to be doing is going to be taking whether it's an expression, an equation, an inequality. We're going to be taking those and substituting a certain value in to see if the piece is true, whether the equation is true, whether the inequality proves true. And that's what we're going to be doing today. So basically, what we're doing, it says substitute 8 in for x. So we're going to rewrite the statement, but in place of the x, we're going to put an 8, and we're going to see if this statement holds true. So 8 plus 4, 8, 9, 10, 11, 12. So we look at it, and 8 plus 4, 8, 9, 10, 11, 12. So 12 equals 12. That is a true statement. All right. So if it happens to be a false statement, then we want to find a value that would make it true. So this is a greater than sign. So they want us to substitute 4.5 for G. So we're going to go 3 times 4.5 greater than 15. We have to see if that's true. So I'm going to take this 4.5 and I'm going to bring it over here and I'm going to make it into an improper fraction. So 4 times 2 is 8 plus 1 is 9, 9 over 2. This whole number can go over 1. We get 27 over 2. So that goes in 13 times to make 26. So that would be 13.5. So is 13.5 greater than 15? That's a false statement. So we'd have to figure out what would go here to make it a true statement. Find a value that would result in true. Well, 3 times 5 would be 15, and 15 is not greater than 15. So anything bigger than a 5 would hold true to this statement. So you could say 6, 5.5, 7, 8, all those would be true. So anything greater than a 5 would make that statement true. Okay? All right. So I'm going to move the dot can down a few more. Here we go. All right, so we have f divided by 4 is less than 2. So we're going to substitute in 8 for f. So we have 8 over 4 less than 2. Well, 8 divided by 4 is 2. And is 2 less than 2? No, that's a false statement. And we would have to find something smaller than an 8 to result in that statement. So f value would have to be something less. So we could say a 4, because 4 divided by 4 is 1, and is 1 less than 2? Yes. So we could find any number that could go in place of the f to make that statement true would have to be anything smaller than an 8. Okay, it could be 7, could be 7, my goodness, it can be 7.99 is still less than the 2. But that's what we're doing. So here we have to take the h and substitute in 25 and 8/10. So we have 14 and 2/10 less than or equal to 25 and 8/10 minus 10 and 3/10. So to make sure we're correct, we bring it over to the side. And remember, when we're subtracting decimals, we have to line up the decimal point. So when all is said and done, when we finish this one, we get 14 and 2/10. Is that less than or equal to 15 and 5/10? And that is a yes, so that is a true statement. This is smaller than or equal to this. So we're looking at this one. 4 equals 8 divided by h. So they want to know, is 4 equal to 8 divided by 6? Well, this doesn't look right at all. So just to prove it, 8 divided by 6, right away we have 1 and 2 6. So 4 is not equal to that. 4 is not equal to 1 and 2 6. So that's a no-no. So what would be the h in order to be it? H would have to be 2, because if we look at it, 8 over a 2 would equal 4. So that would be what would hold it true for that number. So we're basically saying, is this true or false? This is obviously a false statement. All right, so now last but certainly not least, is 3 greater than 1.5 plus a fourth? Well, this is 3 is greater than this because we only have one whole number here. So this automatically is a true statement. However, we have to get the outcome here. So we have 1.5 plus a fourth. I gotta raise this up. Sorry about that, kiddos. I'm gonna move it up here. 1.5 plus a fourth, common denominator. Just moving that over. So 3/4. So 1, and this one right down here is 1 3/4. You just can't see it. So is 3 greater than 1 3/4? Yes, that's a true statement. This is what we're proving during this unit. And as always, this is Mrs. Bobby, yours truly, and I love math.